Okay, so moving on with our single factor analysis of variance. Next up for us is we need to review some statistical notation. We're going to get some new symbols in this chapter, and we're going to see some old symbols with maybe a little bit of a twist in them. So let's start going through all the symbols we're going to need to run this analysis of variance. The first symbol let's talk about is lowercase n. We've had this one before, and it basically means the same thing now. It's the number of scores in a treatment condition. Since this is independent measures, and therefore only every person only gets measured one time, we could also say this is the number of people in the treatment conditions. But notice that we are often going to have 3 treatment conditions. Remember, the definition here is typically for an ANOVA 3 or more. Again, technically we can do 2, but 3 or more treatment conditions. Again, 0 milligrams, 10 milligrams, 20 milligrams, right? Each one of those treatment conditions has a separate independent sample. So in reality, we're going to have, in most cases, 3 of these. How many folks were in the first sample, second sample, and third sample? If there were 4 samples, we'd have a little n4. If there were 5 samples, we'd go all the way out to however many samples there are. But most every problem we're going to look at in this course is going to have 3 treatment conditions. So we would need 3 sample sizes. Note again that because it's independent measures, these numbers could all be different. I could have 10 people in one group and 8 people in another group and 15 people in a third group. We try to make them all even in research, but people drop out and that sort of a thing. So we have to keep track of how many folks or how many scores officially are in each group. Next, capital N. Now the lowercase n really means more or less what it's always meant. Starting in chapter 1, we started using the capital N to say it's the number of scores from a population. We're twisting that a little bit in this chapter. What we're going to say is that the capital N is the total number of scores in the study. So if I had 5 scores in condition 1 and 5 scores in condition 2 and 5 scores in condition 3, if all the groups were the same size, the total number of scores for the entire study would be 5 plus 5 plus 5, 15 scores. So you can get the value for capital N simply by adding all the lowercase n's together. So it's the total number of scores in the entire study. Next up for us is something new. It's a lowercase k. And this symbol isn't quite universal. You could find different symbols used in different statistics textbooks here. But k is the number of treatment conditions. So with the example I keep using, if it's 3 different levels of medication, 0, 10, and 20 milligram doses, that's 3 treatment conditions. So it's basically saying how many groups are there. So again, for most of our problems that we'll be working on in this course, K will be 3 treatment conditions. Now, don't confuse the number of treatment conditions with the number of factors. Remember, a factor is just a new way of saying independent variable or a new way of saying treatment. And remember, the only thing we're ever going to actually do, both in this chapter and the next, is single factor. We're only ever doing one factor at a time. So the way to think about this is when you're looking at the groups, ask yourself, what's the difference between them? So if I have a sample of males and a sample of females and I'm measuring them both on some similar task or some identical task, I would have 2 different samples, a sample of men and a sample of women. I wouldn't have the third one. But there's only one factor. What's the difference between the groups? Biological sex. That's the factor. K is the number of levels of that factor. So typically, again, that's going to be 3 because normally we're going to have 3 groups and each group is in a different version of the factor. So that's a new one for us. Next up for us is the letter capital T. A lowercase t, remember, was for a t statistic. Now that we have a capital T, it stands for the term treatment total. Treatment total. So it is the summation of the raw scores for a treatment condition. So your first group will have its own treatment total, not how many scores there are, That is one of the ends. What's the value of those scores? So that example we were looking at earlier on page 335, table 12.1, for example, just go all the way to the third group. 1, 2, 2, 0, and 0 are the scores. So lowercase n for the third group would be 5. But the t, the treatment total for that group, would be 1 plus 2 plus 2 plus 0 plus 0. So it would be 5 points. So their treatment total is 5. So you get that again by summing up the raw scores. So every group will have its own treatment total. So how many scores are in the first sample, and what was the sum of their scores for the first sample? How many scores in the second? What's the sum of their scores? How many scores in the third? What's their sum of the scores in the third? And then we need a G. G stands for grand total. T was treatment total. G is grand total. So this is the summation of all the raw scores for the entire study. Capital N was the number of scores for the entire study, and you could get that by adding all the little n's together. G is the grand total of all the raw scores. You can get that by adding all the t's together. So if we add up the treatment, you can think of these as little subtotals. Add up the subtotal for group 1, get the subtotal for group 2, get the subtotal for group 3. If you add all the subtotals together, you get the grand total. Now the last new symbol that we have here is a symbol that is, I'll write it off to the side here, a little bit out of room. It's a capital MS. We have a symbol SS for sum of squares. It's a calculation we do to get variance. MS stands for mean of squares. So it's a similar idea, but it's the mean of squares. What does that in actuality mean to us? This is simply a new way of saying variance. It's the same idea, it's the same definition. Variance is the average square distance of raw scores from the mean, right, for any set of data. MS, or mean of squares, is just what they call variance in an ANOVA. So again, we see some new terms. Factor is a new term for an old idea. MS, or mean of squares, is a new term for an old idea. So when you see MS, it just means variance. So these are all the essentially new or newish statistical notation symbols that we're going to need for running these ANOVAs. So next up for us then is to start walking through the 4 steps of our hypothesis testing process. As I referenced in an earlier clip, it's really kind of 5 steps, and we'll see what I mean by that in the very next video.